Right, so this is a simulation. You can go to the website and do this yourself. So I've paused the animation at the moment. So this is what we've looked at in the previous video of a solid diagram with individual particles. So this is neon, which is just single individual atoms. And you can see there, like we drew in the previous video, they're in nicely ordered rows because it's a solid. And if we go to a liquid, they're more random arrangement, but they're still quite close together. And in a gas, they're far apart. But this 2D static diagram only shows part of the picture. So if we look at the animation, we can see a bit more detail. So if we play the animation, you can see those particles, so those solid particles can't move past each other, which is what we said on the previous video, but you can see they're vibrating or jiggling about a fixed position. So there's still movement there. So it's incorrect for us to say that there's no movement because those particles are still vibrating. It's still movement. They have some kinetic energy. If we then go to a liquid, so you can see that those particles can now, they're not moving very fast past each other, but some of those particles are moving past each other. And you can see the odd one up here is escaping, and that's some of the liquid evaporating. So you can see there's a bit of evaporation going on, but then sometimes you also get some condensation because the particles that were a gas come back and rejoin the liquid. So you've got an equilibrium there of the liquid evaporating and then the gas condensing. If we go to a gas, we can see that the particles are far apart and they're not touching each other, although they do occasionally collide. So because they're moving fast and in all random directions, they will collide with each other. But if we draw a static diagram of them, we'd always have them far apart and not touching to show that they're normally far apart. So that's a simplified version with neon, because neon's individual particles. We can look now at a more complicated version. So if we choose water instead, so if we have, so we know that solid water we would normally call ice. So if you look at, could zoom in and look at the particles in ice, you'd see these water molecules. The water molecules are two hydrogen atoms and an oxygen atom chemically joined together. So you get this kind of like Mickey Mouse shape with the Mickey Mouse ears above the face. So you can see then in a solid, so in ice, you've got those molecules still in fixed positions, but they are vibrating about fixed positions. And then in water as a liquid, you can see again that they move past each other. So they're in more random arrangement and they can move past each other. And then when we get steam, which is gas, water that's been turned into a gas, you can see those water molecules are moving fast and moving in all directions. Okay, thank you for listening. See you next time.